Hello viewers, in today's class we are going to discuss one important topic from three-dimensional geometry, right? So here we have to discuss the concept of foot of the perpendicular and image of a point with respect to a given line, right? Now here we have the problem, find the coordinates of the foot of the perpendicular, length of the perpendicular and equation of the perpendicular drawn from the point whose coordinates are 5, 4, 2 to the line whose equation is given here, and also we have to find the image of this point with respect to this line, right? So let us start. Now see, here we are given the equation of a line, right? Suppose this is the line, and here the equation of this line is given as this is the vector equation. So we have vector r minus I cap plus 3j cap plus k cap and lambda 2i cap plus 3j cap minus k cap, right? Now if we want to convert this vector equation into Cartesian form, we can write it as x minus x1 over a, y minus y1 over b, and z minus z1 over c, right? So this line is given, and this line passes through the point x1 y1 z1, and x1 y1 z1 is the point which is given here, that is minus 1, 3 and 1, right? So the coefficients of I cap, j cap and k cap, right? And this line is parallel to this vector, right? So the drs of this line are given by the coefficients of I cap, j cap and k cap. So the drs are a, b, c, and these are given as 2, 3 and minus 1, right? So now if we take this information to this equation, then the Cartesian equation of this line is given by x minus x1, so this is plus, so x plus 1 over 2, then we have y minus 3 over 3, and then we have z minus 1 over minus 1, right? So this is the Cartesian equation of this given line. Now here we are given a point P, and suppose the point P lies somewhere here, and we have to find the coordinates of the foot of the perpendicular, right? So from here, if we draw the perpendicular, and let us say this point is M, and we have to find the coordinates of this point M, right? So let us take the coordinates of this point M as alpha, beta and gamma, right? Okay, so here the Cartesian equation is given as this, and let us take r, and r is a scalar, and we are taking r because we want to have the coordinates of the general point on this line L, right? So x plus 1 over 2 equal to y minus 3 over 3 is equal to z minus 1 over minus 1 is equal to r, right? So now from this equation we have x plus 1 over 2 is equal to r, then we have y minus 3 over 3 is equal to r, then z minus 1 over minus 1 is equal to r, right? Now if we solve these equations, we get x is equal to 2r minus 1, y is 3r plus 3, and z is equal to minus r plus 1, right? So x, y, z, which are written in terms of r, gives the coordinates of the general point lying on this line L, right? And here this point M, whose coordinates are alpha, beta, gamma, it lies on this line L, right? So we can take this x coordinate as alpha, this as beta, and this as gamma, right? So now the coordinates of this point M can be written as 2r minus 1, then we have 3r plus 3, and we have minus r plus 1, right? So now here we have the coordinates of M in terms of r, and the coordinates of this point P are given as 5, 4, and 2, right? So now let us find out the drs of this line PM, right? So drs of PM are given by the difference of the coordinates, right? Because if we have 2 points whose coordinates are x1, y1, z1 and x2, y2, z2, then the drs are given by x2 minus x1, y2 minus y1, and z2 minus z1. So here x1, y1, z1 is 5, 4, 2, and x2, y2, z2 is 2r minus 1, 3r plus 3, and minus r plus 1, right? So the drs of this line PM is given by 2r minus 1 minus 5. We'll subtract the coordinates, and here we have 3r plus 3 minus 4, and then we have minus r plus 1 minus 2, right? So now we can write 2r, this is minus 6, and here we have 3r, this is minus 1, and here we have minus r minus 1, right? Okay, so now here we have the drs of PM, and we know the drs of the line L, that is 2, 3, and minus 1. Now we see that the line PM is perpendicular to the given line L, right? Because we have to find the foot of the perpendicular, so obviously this line PM is perpendicular to the given line L, right? And we know that if two vectors or two lines are perpendicular, then we have the condition a1 a2 plus b1 b2 plus c1 c2 is equal to 0, and the product of the drs and their sum is equal to 0, right? So a1 b1 c1 are the drs of the line, and a2 b2 c2 are the drs of this line PM, right? So now we have 2 times 2r minus 6 plus 3 times 3r minus 1, and then we have minus 1 times minus r minus 1 is equal to 0, right? Okay, so now this is a linear equation in R, and we can solve it. So we have 4r minus 12, then we have 9r, then we have 3, and here we have plus r and plus 1, right? So we have 9 plus 4 13, and r 14 r, and here we have minus 12 minus 3 minus 15 plus 1 minus 14 is equal to 0. So 14r is equal to 14, so r is equal to 1, right? So here we have obtained the value of r as 1, and now we can substitute this value of r over here, because we'll get the values of alpha, beta, and gamma, right? So taking r is equal to 1 over here, we have 2 times 1 minus 1, so we have 2 minus 1, that is 1. Here we have 3 times 1 plus 3, so we have 3 plus 3 6, and here we have minus 1 plus 1, that is 0. So alpha is 1, beta is 6, and gamma is 0, right? So the coordinates of this point are now 1 comma 6 comma 0, right? So the foot of the perpendicular, which is M, has the coordinates 1 comma 6 comma 0, right? So we have obtained the coordinates of the foot of the perpendicular. Now let us find out the length of the perpendicular. So viewers, in order to find out this length PM, we can use the distance formula in three-dimensional geometry. So PM is given by square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square, right? So x1 y1 z1 is 542, x2 y2 z2 is 160, right? So now we have here 1 minus 5 square, 1 minus 5 square plus 6 minus 4 square, and then we have 0 minus 2 square, right? So now we have minus 4 square here, and here we have 2 square, and here we have minus 2 square, right? So this is 16, minus 4 square is 16, this is 4, this is also 4, so we have square root of 24, right? Which can also be written as 2 root 6 units, right? So the distance PM is equal to square root of 24 units, or 2 times square root of 6 units, right? So now we have obtained the foot of the perpendicular, which is 160. The length of the perpendicular is 2 root 6 units. Now we have to find the equation of the perpendicular drawn from this point on this line, right? So now we have to find the equation of PM. So to find out the equation of PM, we'll make use of the equation of line, that is x minus x1 over x2 minus x1, y minus y1 over y2 minus y1, z minus z1 over z2 minus z1, right? So here we have to find the equation of PM, and P is 542 and M is 160, right? So this point can be taken as x1 y1 z1, this point can be taken as x2 y2 z2, right? So now substituting these coordinates over here, we have x minus 5 is equal to y minus 4, then we have z minus z1, that is 2, and in the denominator we have x2 minus x1, so x2 minus x1 is 1 minus 5, and then we have 6 minus 4, y2 minus y1, then we have 0 minus 2, that is z2 minus z1. So this is x minus 5 over minus 4, this is y minus 4 over 2, and this is z minus 2 over minus 2, right? So this is the Cartesian equation of this perpendicular PM, right? And here we see that the drs of PM are minus 4, 2 and minus 2, right? We can also write this vector, this Cartesian equation in vector form. So the vector form of the line is r vector, vector A plus lambda vector B, right? So now here we can convert this Cartesian equation into this form. So vector r is equal to vector A. Vector A is the point through which the line is passing. So here we can take vector A as 5, 4, 2. So we have 5i cap plus 4j cap plus 2k cap and plus lambda, and this vector B is the vector to which this PM is parallel to, right? So this vector B is given by the direction ratios of the line, right? So we have vector B as minus 4i cap plus 2j cap minus 2k cap, right? So this is the vector equation of this perpendicular, that is PM, right? So now we have obtained the foot of the perpendicular, length of the perpendicular, and equation of the perpendicular, and now we have to find the image of this point P with respect to this line L, right? So now viewers, let us find out the image of this point P with respect to this line. So let us extend this PM and let us take this point Q, right? And if we take this point Q as say P, Q and R, right? So the coordinates of this point Q can be taken as P, Q, R, and Q is the image of this point P. So here this line L will act as a mirror, right? So the image of this point P is Q, whose coordinates are P, Q, R, and we have to find the value of P, Q and R, right? So what we will do, see here this point M, see here we have P, then we have M, and then we have Q, right? So the coordinates of P are 5, 4, 2, and Q has coordinates P, Q and R, and this point M is 1, 6 and 0, right? And we know that this image Q and the point P are equidistant from this point M, or in other words we can say that M is the midpoint of PQ, right? So PM must be equal to MQ, right? So here we can find out the coordinates of this point M, which is the midpoint of PQ, right? So by the midpoint formula, and the midpoint formula is given as x1 plus x2 over 2, then we have y1 plus y2 over 2, and then we have z1 plus z2 over 2, right? So this point P is x1, y1, z1. This point PQR is x2, y2, z2, and this point is x, y and z, right? So M is the midpoint of PQ, right? And we have x1 plus x2 over 2, then we have y1 plus y2 over 2, and then we have z1 plus z2 over 2. So x1 plus x2 over 2 is equal to x, this is equal to y, and this is equal to z, right? So now x is x1 plus x2 over 2, and x is 1, and x1 is 5, and x2 is p, right, over 2. Now this is a linear equation. So we have 2 is equal to 5 plus p. So p is 2 minus 5, that is minus 3, right? Now similarly, y is y1 plus y2 over 2. Now what is y? Y is 6. What is y1? Y1 is 4 plus y2. Y2 is q over 2. Now again solving it, so we have 12, here we have 4 plus q, and q is 12 minus 4, that is 8, right? And then we have z is equal to z1 plus z2 over 2, and what is z? Z is 0, and what is z1? Z1 is 2, and what is z2? Z2 is r, right, over 2. So now solving it, so we have 2 plus r is equal to 0, r is equal to minus 2, right? So the value of p is minus 3, the value of q is 8, and then the value of r is minus 2, right? So the image of this point P with respect to this line L is given by minus 3 comma 8 comma minus 2, right? So viewers, this is how we solved this interesting problem, and here we have seen that this problem contains a lot of concepts in three-dimensional geometry, right?